What first one? There is four. What logic have you used to solve this question? What logic have you used to solve this question? Are it answer? Okay, fine. So it says the in x is between 0 to reason 1. There are two reasons out there. That is from the origin out there. Let's say there are two reasons. This is the reason 1. This is the reason 2. So what I can write is in reason 1, the potential energy is always A, right? It is given the total energy of the particle is 3A, isn't it? So like kinetic energy plus potential energy is what? Total energy is 3A, no? So kinetic energy plus potential energy is what? 3 always, right? Mentioned in the question itself, right? So in reason 1, hello. Yeah. In reason 1, potential energy is A. So what is kinetic energy? Kinetic energy will be 2A. In reason 2, we have what? Potential energy is 0. So what I can write? K will be equal to what? 3. So we have to find out the what? Diffusive wavelength. So let's say in this reason, so lambda 1 I can write as h by p, at h by p1 and lambda 2 is h by p2. And like p is what? Root 2 mk, na? So lambda 1 by lambda 2 will be equal to simply p2 by p1, and p2 by p1 is equal to what? K2 by k1. And k2 by k1 is what? Like 3 by 2 sort of. 3 by 2, so it's 9, n is equal to what? Very simple, no? Isn't it? Now this one is also going to erode as well. It says we have a conductor that has independent resistance, temperature independent resistance. So we first thing we have a conductor out there. It's a conductor has a temperature. It has a temperature dependent resistance is R is there. Okay. So apart from that, we have what? Total heat capacity is 4. Let's say the heat capacity is 2. E is equal to 4 is given. Now it comes at the end, at the moment T equal to 0, it connects to a DC voltage V. Let's say this voltage V is connected. So what I can write is, assuming the thermal power dissipated in the surrounding, like it also heat dissipate temperature in the surrounding as well. Fine. Got it. No? Although we define temperature dependence of the like different mentioned. And T naught is what? T naught is the surrounding temperature curve. Yeah. And T is T1. So it is like it seems like what? The power dissipated, like first thing there is a this is like dissipated heat sort of thing, like dissipated heat particularly. So what I can write is this is the thermal power dissipated in the surrounding is given by this particular thing. And what I know is the heat emitting by this rod is what? Uh, I square R is what? I square is the heat, na, isn't it? This body, and also it emits what? This amount of heat, no? Q into like 4 minus T20, isn't it? That is equal to what? Ms dt by dt, isn't it? Because this is what? dq by dt, isn't it? And this actually I can write as C dq also I can write what? T dt, na? So, like I square R is the power, and this is the what? This is which power? Loose ones. This is like thermal dissipated in the surrounding. So it should do what? Like I is what? Simply is not sure it is V square by R, isn't it? V square by R is the dissipated power, and it is the like what? Not going to it's a T minus T not going to. So this power has been emitted to the surrounding, and out of this particular like so this equation means what? Temperature should increase or decrease. This is the dissipated power, and this is the emitted power, right? Emitted or like dissipated energy. So like T dt by dt should be positive, right? Uh, I should write as what? I should write like in this equation. This is equation, right? And I should write the C as this is equation. C dt upon. Like this should I should write in place of this. Like I should write v square by r. V square by r minus q into t minus t naught. That should be equal to v. And I can integrate at t equal to 0 to the temperature was t naught. And then after that we have what? At any time t is t, it is 0 to t. Then I can write as what? C ln of v square by r minus q into t minus t naught. That should be from t naught to t is equal to and upon what? Minus q is equal to t. Right. So it is what? C ln of v square by r. Hello. Minus ln of v square by r. Sorry, it is v square by r minus q into t minus t naught minus ln of v square by r. That should be equal to minus qt out there. Then I have minus qt by c. Minus qt by c. And second, when I'm writing the q, it's a 4 times t. Just a second. Okay. And then I can write, and t is what? C is against 4. Fine. I can put the values out. So we have ln of v square by r minus 4 into t minus t naught upon v square by r equal to minus t. Then I can write as what? V square by r minus 4 into t minus t naught equal to v square by r into e to power minus t. Then I can take the v square by r into 1 minus e to power minus t equal to 4t minus 4t naught. So let's add the, like, it is what then? 4t naught plus v square by r into 1 minus e to power minus t upon 4. That should be equal to what? T. So t is what? T is equal to t naught plus v square by 4r into 1 minus e to power minus t. Correct? It's like simply 1 is equal to what? Okay. Now this question.